Okay, so now we're going to be looking at how do we test the difference between means when we have small independent samples. This is analogous to what we learned in section 7.3 with one sample. Now we're going to perform a t-test for the difference between two means when we have small independent samples. The two-sample t-test is used if the samples sizes are less than 30, they are from normally distributed populations, then a t-test can be used. The conditions that must hold to use this t-test for small independent samples is the samples must be randomly selected, the samples must be independent of each other, and the populations must be normally distributed. The standardized test statistic for this is the only real difference between what we did in section 8.1 and what we're doing now in section 8.2. In this case, instead of having a standardized statistic that is a z equals, it's a t equals, but the rest of this looks very similar. The big difference is going to be finding this standard error here. That standard error is going to be determined by whether we have population variances that are equal or not equal. And I'm going to do an example of both kinds for you. Now, if the variances are equal, we're going to first find this piece, which is sample size 1 minus 1 times the standard deviation of sample 1 squared plus sample size of sample 2 minus 1 times the standard deviation of sample 2 squared divided by sample size 1 plus sample size 2 minus 2, and take the square root of all that. Then take that quantity that we just computed here times the square root of 1 over sample size 1 plus 1 over sample size 2. And the degrees of freedom then is sample size 1 plus sample size 2 minus 2. If the variances are not equal, then the standard error is really much easier. It's just standard deviation of sample 1 squared over the sample size of sample 1 plus the standard deviation of sample 2 squared over the sample size of sample 2. The degrees of freedom then is the smaller of either sample size 1 minus 1 or sample size 2 minus 1, whichever one is smaller. So we can look at this flow chart. If both samples sizes are at least 30, then we're going to use the z-test that we learned in section 8.1. If no, then we have to ask, are both of the populations normally distributed? If the answer is no, then you can't do it at all, right? It's for a more advanced class. If the answer is yes, then we have to ask, are both population standard deviations known? Because if the answer is yes, then we're going to use the z-test like we learned in 8.1. And then if no, then we're going to be doing the t-test, but we still have to decide which standard error to use. And we do that by determining whether the population variances are equal or not. If they're not equal, then we use this standard error, and if they are equal, we use this standard error. Okay, so in words, it's almost the same. We determine the hypotheses, we identify the significance level, we determine the degrees of freedom by whether the sample sizes or the variances are equal to each other or not equal to each other. Then we find the critical values using the t-table, which is table 5 in your appendix. We determine the rejection regions from the alternative hypothesis and the critical values. We calculate the standardized test statistic, compare it to the rejection region. If the standardized test statistic right here is inside the rejection region, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. So let's look at an example. This first example, we're going to be looking at population variances that are not equal. We're going to be comparing the math scores from two different teachers at the same school. And here is our sample data that was collected from these two teachers. And remember, the population variances are not equal to each other. So our null hypothesis is that they are the same versus they are different. That makes this a two-tailed, this is not equal to or alternative, makes this a two-tailed hypothesis test. We determine from the problem that our significance level is 0.01, and then our degrees of freedom is the smaller sample size, which was 8, minus 1, so our degrees of freedom is 7, We use this degrees of freedom in Table 5 to find the significance, the critical values of negative and positive 1.895. The rejection region then is everything greater than positive 1.895 and everything less than negative 1.895. Now, the test statistic is where the differences are between the two types of problems we're looking at here in 8.2. So let's look at that next. Whoops, let me go back. So it's sample mean 1 minus sample mean 2 minus 0 over the sample standard deviation squared divided by 8, which is the sample size of sample 1, the sample standard deviation of sample 2 squared divided by the sample size of sample 2. Add those two fractions, take the square root, and we get approximately 0.922, which is right about here, not inside our rejection region, so we fail to reject the null hypothesis. Now let's look at another example, but this time the population variances are assumed to be equal. So we're going to use the other formula for the standard error. Everything else is still the same. Now in this case, this manufacturer claims that their calling range is greater than their competition. So our alternative hypothesis is mu1 is greater than mu2. The significance level is given in the problem of 5%. Degrees of freedom is sample size 1 plus sample size 2 minus 2, which is 28. You use this degrees of freedom, and table 5 to determine the rejection region is 1.701, and everything greater than, this is a one-tail test and also known as a right tail test. So this 5% is all in the upper tail, so this denotes our rejection region. Now to determine the test statistic, we have to do this with a little more work. So let's look at first the standard error. Remember this formula, we saw it a few slides ago. Let's do it together. Sample size 1 minus 1 times standard deviation 1 squared of sample 1 plus sample size 2 minus 1 times standard deviation of sample 2 squared. Compute those two products, add them together. Take that and divide it by sample size 1 plus sample size 2 minus 2. Once you get that fraction, take the square root of it, and to that computation, multiply 1 over sample size 1 plus 1 over sample size 2, and take the square root of this piece. Remember again, if you're going to do this in pieces, keep many significant digits, 5, 6 different place values while you're in the middle of this calculation. And in the end, you should get 13.8018. So then we calculate the standardized test statistic, which is sample mean 1 minus sample mean 2 divided by the standard error that we just computed up here. And that's approximately 1.811. We now compare this to the rejection region. This time it is inside the rejection region, so we reject the null hypothesis and say at the 5% level of significance, there is enough evidence to support the manufacturer's claim that its phone has a greater calling range than its competitors. That's the end of section 8.2. Now go to the problems assigned in Course Compass for section 8.2 and practice some of these problems.